Bismillahirrahmanirrahim. Assalamu alaikum, dear student. I do hope you will be in best of your health. In today's lecture, we will learn inverse Laplace transform of the basic function, and using Laplace transform, we will solve some first order and second order differential equations. So let's start our today's lecture. Here, basic inverse inverse transform are given. First, we have learned a Laplace transform 1 is equal to 1 by s. If we take inverse, Laplace inverse of 1 by s, we will get uh, 1. And Laplace transform, we have already learned t power n is equal to n factorial divided by s power n plus 1. And if we take inverse, we will get t power n is equal to Laplace inverse of n factorial divided by s power n plus 1. Similarly, we have learned earlier that the Laplace transform of sine kt is equal to k divided by s square plus k square, and if we take its the inverse of Laplace of the right hand side, we will get the sine function. Uh, Similarly, we have Laplace transform of cos of kt is equal to s divided by s square plus k square. If we take inverse of the right hand side, we get cos of kt again. Similarly, Laplace transform of sine hyperbolic kt is equal to k divided by s square minus k square. Uh, Again, if we take the inverse of the right hand side, we get sine hyperbolic kt. Laplace transform of cos of kt is equal to s divided by s square minus k square. Again, if we take the its inverse of the right hand side, we get cos hyperbolic kt. And we have learned Laplace transform of e power at is equal to 1 by 1 divided by s minus a. If we take the inverse of 1 divided by s minus a, we get e power at. These are the basic Laplace transform along with their inverse Laplace transform. Keep in mind these transformation. We will solve its related question. Similarly, Laplace transform of derivative is maybe defined as uh, if f prime, so and so for f n minus 1 derivative are continuous on interval 0 to infinity and are of exponential order. If f of n of t is piecewise continuous on interval 0 to infinity, then Laplace transform of n derivative is equal to s power n Laplace transform of f minus s power n minus 1 f of 0 minus s power n minus 2 f prime of 0 minus so and so forth minus f power n f n minus 1 derivative at 0, where f of s is equal to Laplace transform of f of t. This NS formula is difficult to understand. I will explain with one n is equal to 1, that is first derivative, n is equal to 2 as like the second derivative, and n is equal to 3 third derivative, and we will generalize this. If n is equal to 1, the dy by dt is equal to s y of s minus y of 0. If we have n is equal to 2, then it means that we have second derivative d2y divided by dt square is equal to s square y of s minus s y of 0 minus y prime of 0. If we have n is equal to 3, that is third derivative d3y divided by d3 is equal we will have Laplace transform is equal to s3 y of s minus s square y of 0 minus s y prime of 0 minus y double prime of 0, and we can generalize its with for the nth derivative d n y divided by dt power n s power n y of s minus s power n minus 1 y of 0 minus s power n minus 1 y prime of 0 minus and so forth minus y power n minus 1. Here power denotes derivative. This is n minus 1 derivative and minus 2 derivative, and this is uh, and this will be at last we have, this is mistakenly written, at last we will have y of 0. Uh, so, dear student, these are the Laplace transform of first derivative, second derivative, and we have generalized for the nth derivative. Example 1, we have to find Laplace transform of 1 divided by s power 5 and Laplace inverse of 1 divided by s square plus 7. Uh, Earlier we have uh, learned formula Laplace transform of t power n is equal to n factorial divided by s power n minus 1, and we will take its inverse, we will get t power n. So here we have given Laplace inverse of 1 divided by s power 5. If we multiply 4 by its 4 by 4 factorial and divide by 4 factorial, we will get the Laplace transform of t power 4. 1 by 4 factorial t power 4. Similarly, uh, we want to find Laplace transform of inverse transform of 1 divided by s square plus 7. Uh, this is the Laplace inverse of related to sine of kt. For sine, we have to we must have square root of 7. So this 7 may be written as this 7 may be written as square root 7 square. We multiply by square root 7 and divide by square root 7. We will have the inverse transform of sine of example. In example 5, we have to find we have to solve the second order ordinary differential equation. Solve y double prime minus 3y prime plus 2y is equal to e power minus 4t, y of 0 is equal to 1, and y prime of 0 is equal to 5. uh, First of all, in again the given differential equation, we will apply Laplace transform on each term. uh, for second derivative, we will have s square y of s minus s y of 0 minus y prime of 0. For first derivative, we have minus 3 into s y of s minus y of 0. And for the third term, we have 2 y of s, that is the Laplace transform of y. And Laplace transform e power minus 4t is equal to 1 divided by s plus 4. If we take and we use the boundary conditions, and uh, we take the y of s common from left hand side terms, we have s square minus 3s plus 2 y of s is equal to s plus 2 plus 1 divided by s plus 4. If we further simplify this, we will have y of s is equal to s square plus 6s plus 9 divided by s minus 1 into s minus 2 into s plus 4. Uh, it is hard to find its inverse Laplace from of right hand side. So we will simplify this with the help of partial fraction. For using now partial fraction, we can write s square plus 6 s plus 9 divided by s minus 1 into s minus 2 into s plus 4 is equal to a divided by s minus 1 plus b divided by s minus 2 plus c divided by s plus 4. If we multiply uh, the denominator of the left hand side with the right hand side term, we will have uh, s square plus 6 s plus 9 is equal to a into s minus 2 into s plus 4 plus b s minus 1 into s plus 4 plus c s minus 1 into s minus 2. If we put s is equal to 1, we will get value of a is equal to minus 16 divided by 5. If we put s is equal to t, we will get the value of b is equal to 25 divided by 6. If we put s is equal to minus 4, we will have s c is equal to 1 by 30. If we put the value of a, b and c in this equation, we will have y of s is equal to minus 16 divided by 5 divided by s minus 5 plus 25 divided by 6 divided by s minus 2, 1 plus 1 divided by 30 divided by s plus 4. Now we can easily find their inverse Laplace transform. So applying inverse Laplace transform, we will have y of t is equal to minus 16 divided by e power t plus 25 divided by 6 e power 2t plus 1 divided by 30 e power minus 4t. Now we will solve some question from the exercise 7.2 and problem 1 to 30. Uh, Use appropriate algebraic simplification uh, to find the given inverse Laplace transform. Uh, First question is Laplace inverse Laplace transform 1 divided by s over 3. We have formula inverse Laplace transform is n factorial divided by s power n plus 1 is equal to t power n. Here s power is 3. This power may be written as uh, uh, 2 plus 1, where here n is equal to 2. We multiply with 2 factorial and divide by 2. We will have the Laplace transform, inverse Laplace transform of this function is equal to 1 by 2 t square. In question number 7, we have to find inverse Laplace transform 1 divided by s square minus 1 by s plus 1 divided by s minus 2. Uh, we will use this formula. Uh, eh, for the third term, we will use the formula Laplace transform e power t is equal to 1 by s minus a. If we take the inverse of right hand side, we get e power at. Here a is equal to 2. So Laplace inverse transform of 1 by s minus Laplace inverse transform 1 by s plus Laplace inverse transform 1 divided by s minus 2 is equal to, this is Laplace transform of t, and from this this is the inverse Laplace transform 1, and this is the inverse Laplace inverse will be equal to e power 2t. Question number 22, we have to find the inverse Laplace transform of s minus 3 divided by s minus square root 3 into s plus square root 3. We cannot directly find its inverse Laplace transform. We will simplify this with the help of partial fraction. For the partial fraction, we have s minus 3 divided by s minus square root 3 into s plus square root 3 is equal to a divided by s minus 3 square root plus b divided by s plus square root 3. If we simplify this, we will have s minus 3 is equal to a into s plus 3 square root 3 plus b s minus square root 3. If we put s is equal to square root 3, we will find the value of a is equal to square root 3 minus 3 divided by 2 into square root 3. And if we put s is equal to minus square root 3, we will have value of b is equal to square root 3 minus 3 divided by 2 into square root 3. And if we use these values of a and b and the above equation, we will have square root 3 minus 3 divided by 2 into square root 3 Laplace inverse of 1 divided by s minus square root 3 plus square root 3 minus 3 divided by 2 into square root 3 in Laplace inverse of 1 divided by s plus square root 3. And we will have uh, this this is the this for this Laplace transform will be equal to e power square root 3 into t, and for this inverse Laplace transform will be equal to e power minus square root 3 into t. Similarly, question. Now we will uh, uh, solve some first order and second order differential equation. First of all, we will find the solution of first order ordinary differential equation with the help of Laplace transform. Question number 31, dy by dt minus y is equal to 1, y of 0 is equal to 0. We will apply Laplace transform on both sides of a ordinary differential equation given in question number 33. We will have Laplace transform first derivative is equal to s into y of fs minus y of 0, and Laplace transform y will be equal to capital Y of s, and Laplace transform 1 is equal to 1 by s. And we take y of s is equal to y of s. If we take y of s common and y of 0 is equal to 0, we will have s minus 1 into y of s is equal to 1 by s, and capital Y of s is equal to 1 divided by s minus 1 divided by s into s minus 1. We cannot directly solve this. We will simplify this with the help of partial fraction. 1 divided by s minus 1 divided by s into s minus 1 is equal to a divided by s plus b divided by s minus 1. If further simplify this, we will have 1 is equal to a into s minus 1 plus b of s. If we put s is equal to 0, we will have a is equal to 1. If we put s is equal to 1, we will have value of b that is equal to 1. And using this value of a and b in the above equation, we will have capital Y of s is equal to 1 divided by s plus 1 divided by s minus 1. Applying inverse Laplace transform from both sides, we will have uh, inverse Laplace transform 1 by s is equal to 1, and inverse Laplace transform of 1 divided by s minus 1 is equal to e power t. Now we will solve second order differential equation. Question number 35, y double prime plus y prime plus 5y prime plus 4y is equal to 0, y of 0 is equal to 1, and y prime of 0 is also 0. First of all, we will apply the Laplace transform on both sides of a given differential equation. For the second order differential equation, Laplace transform will be equal to s square capital Y of s minus s y of 0 minus y prime of 0. And for the second derivative, also if we use the boundary condition, y of 0 y of 0 is equal to y of 0 is equal to 1, we will have uh, s, and y prime is 0. This will be 0, and we have s square y of s minus s. This is the Laplace transform second derivative. Laplace transform of first derivative will be equal to s capital Y of s minus y of 0. Using this transform in the given differential equation, we will have s square y of s minus s y of 0 minus y prime of 0 plus 5 s capital Y of s minus y of 0 plus 4 y of s is equal to 0. And we simplify this, and using the boundary condition and take y of s common from the left hand side, we have s k plus 5s plus 4 into y of s is equal to s plus 5, and y of x is equal to s plus 5 divided by s plus 4 into s plus 1. We cannot directly find its inverse Laplace transform, so we will use again partial fraction. s plus 5 divided by s plus 4 into s plus 1 is equal to a divided by s plus 1 plus b divided by s plus 4. If we put s is equal to minus 1, we will have a is equal to 4 by 3, and we put s is equal to minus 4, we have b is equal to minus 1 by 3. So using this values of a and b in this formula, we have inverse Laplace transform of s plus 5 divided by s plus 4 into s plus 1 is equal to inverse Laplace transform 4 by 3 divided by s plus 1 Laplace inverse of minus 1 by 3 divided by s plus 4. This is the Laplace transform of e power minus t, and this is the Laplace transform of e power minus 4. So, dear student, we have in solve in detail second order differential question. Let's solve another question. Question number 37: y double prime plus y is equal to square root 2 into sine square root 2 into t. Y 0 is equal to 10 and y prime of 0 is equal to 0. So this is given here Laplace transform second derivative. This is the Laplace transform of first derivative, and if we simplify this, and we have y of s is equal to 2 divided by s square plus 2 into s square plus 1 plus 10s divided by s square plus 1. Here again we cannot find its Laplace transform directly. We will simplify this with the help of partial fraction, and if we simplify this with the help of partial fraction, we have y of s is equal to 2 into 5s plus 1 divided by s square plus 1 minus 2 divided by s square plus 2. If we simplify again further is if we multiply 2 by 5 and plus 1, we have 10s divided by s square plus 1 and 2 divided by s square plus 1. Uh, this is the Laplace inverse Laplace transform will be equal to cos of t, and its Laplace transform will be equal to sin of t, and last term inverse will be equal to sine square root 2t. So, dear student, we have solved in this lecture. We have studied the inverse transform of some basic function, and we have solved using the Laplace and inverse Laplace transform uh, to solve the first order and second order differential question. Hopefully, if you study this lecture keenly, you can easily understand the concept of Laplace and inverse Laplace transform, and using these to solve the ordinary differential equation. So study this carefully. Okay, Allah Hafiz.